In this section, we're going to be talking about a different form of quadratic equations, and it's called vertex form. If you remember, we have looked at standard form, and standard form of a quadratic equation looks like this: ax squared plus bx plus c equals 0, or sometimes it's f of x, or sometimes it's y. So that was standard form, and we've spent a lot of time looking at that and using that with quadratic formula and factoring and things like that. Today we're going to look at something called vertex form. And vertex form of a quadratic equation looks quite different. It looks like f of x, again, or y, or 0 equals a times x minus h all squared plus k. And here are the things that you need to know. The vertex, and we use the vertex in standard form, we're able to come up with it, but the vertex for vertex form is just simply hk. So vertex form, and that's why it's called vertex form, allows us to pull the vertex off really easily. Now, this is the main reason why we've studied completing the square, because in order to do vertex form, we have to complete the square so that we get a binomial squared like this here, and that allows us to get the h and the k. So we'll go through some examples, and I'll talk about how you use completing the square to get it into this form, and then also to pick off the vertex itself, and then how to use that. Here's an example of an equation that's already in vertex form, and I want to start with this because it allows us to really compare and find out what the vertex is without really doing much work. Again, if we remember that the vertex form, the standard vertex form, is this: y equals a times the quantity x minus h all squared plus k. I want to pull out the vertex for this particular equation. And so as you're looking at it, hopefully you're starting to figure out what it should be. Since the vertex is just hk, what would be the h for this equation here? Right? So the 7 is the h. And notice that in the formula there's a minus. So actually the x-coordinate of the vertex, h, is actually positive 7, because the formula is already negative, so we just pulled the number out. If in our equation, if what was in the parentheses was a positive, if it was x plus 7, for example, the value that would come out to the x coordinate of the vertex would be negative. So it's sort of like the opposite, so to speak, because this is minus 7. The opposite of that is positive 7, because the standard formula already is built with a minus in it. Hopefully that makes sense. Then I need the k value to give me the y coordinate of the vertex, and it's the same sign. So this is positive 4, just like it is in the formula. So I'm going to put a 4 as my y coordinate of the vertex. So that's going to be the vertex. Of course, the other thing we know is that the axis of symmetry is the same as the x coordinate of the vertex, because if you remember from when we worked on quadratics before, we had to go through the negative b over 2a to find the axis of symmetry, and that was also the x coordinate of the vertex. Well, if you know the vertex, you also know the line of symmetry, which is just going to be the x coordinate of the vertex. So I'm going to get a vertical line at x equals 7, and then we could find other points, and we'll do that later. But I wanted to show you this and sort of how it works to begin with. The bulk of this lesson is going to be converting to vertex form. And you're going to be given an equation like this in standard form. Okay, but what I'm going to do is I'm actually going to slide that plus 2 kind of down here. So normally we would have moved it to the other side, okay? But because of vertex form having everything on one side, moving the 2 to the other side would then make the other side not 0, or in this case y or f of x. So we're going to leave it on that side, but I'm going to show you how we're going to compensate for that in a minute. So we look at this first part here, this x squared minus 6x, just like we were doing completing the square before. I take the 6, I divide it by 2 and square it, okay? And that, of course, is 3 squared, which is 9. And I'm going to add it in right next to it, like we did with normal completing the square. Normally, with just plain completing the square, we would then add 9 to the other side. But I'm not going to do that for vertex form. Rather than doing that, what I'm going to do is subtract 9 from the same side. Because, if you notice, what I've really done is plus 9 minus 9. I've done nothing to this side of the equation other than kind of in terms of its value. I'm just looking at, because 9 minus 9 is just 0, I added 0 to this side of the equation, which means I didn't change the value of the equation at all, but I'm going to be able to use this x squared plus 6x plus 9 and rewrite it as a binomial square. And as we have already worked through, we know that this is x plus, and the square root of 9 is 3. I can rewrite that as the binomial. So all of this, x squared plus 6x plus 9, is the same as x plus 3 all squared. And what I end up with left over as part of the k is this minus 9 plus 2, which is negative 7. So when I put this into vertex form, I have y equals x plus 3 all squared minus 7. The vertex then is, now remember, the vertex form is minus h, so since I have a plus 3 here, I actually, the x coordinate of the vertex is minus 3, again the opposite like we talked about in the previous slide. And then the k, the y coordinate, is the same sign, so that's minus 7. So there's the vertex, and it's in vertex form. In this case, the a, which is normally right here, is actually just 1. And we'll show you how to use that to graph in a little bit here. And that's it. So the completing the square part, we just slid the 2 to the right, give it some space. We add and subtract on the same side so that I actually am adding 0 to the equation, not changing the value of the equation, yet I've manipulated in such a way that I can turn it into a binomial square. We're going to look at a little more challenging one now. Let's see if I can. Yeah, so here's one. We're going to just move it up to the top. So y squared minus 2x squared plus 8x minus 5. The reason this one is more challenging is because there's a number in front of the x squared. And if you remember when we were doing completing the square, this always needs to be a 1. So I'm going to show you how to deal with that and still be able to work through this problem fairly simply. Okay. So I'm going to first start by doing the same thing that I did before. I'm going to slide that minus 5 over, create some space, because I'm going to have to be adding and subtracting again to turn that, sort of add that value of 0. Instead of dividing everything by negative 2, we're going to be factoring a greatest common factor out of these two terms, because what we want to create is this kind of situation. Okay. And so in order to do that, what you do is you look at the minus 2x squared and the plus 8, and I'm going to actually take a negative 2 out as the greatest common factor, because that will force, when I divide, because greatest common factor, you just end up dividing both terms by negative 2. All right, and this gives me, on the inside, I get x squared minus 4x. Now this minus 5 over here is still here. Okay, the minus 2 stays in front of the parentheses, and in fact, what I really need to do is get rid of this parenthesis here, and I'm going to slide it over because we are going to, we are going to complete the square inside the parentheses. And the thing about that that's interesting is you still have to account for this -2 out in front of it. So here's what that's going to look like. First of all, I complete the square on the inside, so I take the -4. All right, I divide it by 2 and square it the same way that we have before. So that's -2 squared. Anytime you square a negative, it is a positive. I know a bunch of you made that mistake on the quiz, so keep that in mind. Anytime you square a number, it becomes a positive. So this is a +4. Now, your instinct is going to want to be, okay, right away, a -4 on this side. The problem is, this 4 that we put inside the parentheses to complete the square inside the parentheses is still being multiplied by this -2. Okay? So really what I just did is I didn't add 4. I added -8 because -2 is being multiplied by +4. So right now what I did is I did -8 on this side. So what I have to do is the opposite of that, again, for that sort of 0 piece. And so what I need to do is add 8. Okay. Again, this, when I added the 4 in here, I really added a 4 times -2, which is -8. So I added a -8. So now I have to add a +8 to balance that out. And what you'll see here is that I get y equals -2. Now, because I completed the square here, I can just go ahead and change this. Okay, remember the sign from the middle term is what goes in the middle. The square root of this goes here. The square root of x squared goes here. So what I have is x minus 2 squared. It's just the binomial. Then on the right-hand side, well, that's all on the right-hand side, but this +8 minus 5 is a +3. And so putting it into vertex form is now complete. And I have the A. So the vertex is 2, 3. And we'll find some other points here in a little bit. But again, keep in mind, the key component here is I factor out the -2 to get the x squared by itself inside the parentheses. Then I complete the square on the inside, and instead of just subtracting 4 over here, the reality is I just added a -8, -2 times 4, and so I have to add 8 to, again, make no value of the equation change. I subtracted 8, now I add 8, basically I added 0 to that equation. I'm going to go through one more of these, and hopefully that'll make more sense to you. So I have a similar situation here. Here's standard form. Again, I have this 4 in front of the x squared. So the first thing I'm going to do is I'm going to factor the 4 out, and this is x squared plus x. Give it some space. So basically I factored a 4 out. I divided both of these by 4. I'm going to slide this 24 down over here. And give it some room because I know that I'm going to have to be adding or subtracting something in here. Now, I need to figure out what goes in the blank. Now, the thing that you want to think is that this middle term is actually a 1. So, yes, we're going to have some fractions sometimes. I take 1 divided by 2 and square it. Okay, that is 1/4. And so I have to add that in here to complete the square. Now, again, I didn't actually add 1/4. I actually added 1/4 times 4. So I actually added 1. 4 times 1/4 is 1. And so I added 1 to this equation. To compensate for that adding 1, I have to subtract 1 on the same side, again, because 1 minus 1 is 0. Now, what I really have here is y equals 4 times the quantity x, because this is plus. My value here is plus. Then I take the square root of 1/4, which was what I basically did before I squared. So I'm going to have a 1/2 there. So this is 1/2. This is all squared. And then -1 plus 24 is plus 23. My vertex is negative 1/2. Again, remember it's going to be the opposite sign of what's in the binomial. And then 23. The last thing we're going to do is write an equation in vertex form from a graph. So here is an example of a graph. Okay. Alright. So here's a graph. Notice, of course, you have a parabola opening down, so right away you should be thinking, all right, that a value is probably going to have to be negative. Okay. We know the vertex. The vertex is negative 3, 6. And we know a point on the line. This is going to be important. If you recall, vertex form, it's just like this. We know h and k. Okay. So y equals a times, now, because what I technically would do is put negative 3 in for h and 6 in for k. Notice the minus a minus, again, the opposite sign idea. I get y equals a times x plus 3 squared plus 6, because that x coordinate value is going to have the opposite sign of the sign inside the binomial. And we've talked about that, so just make sure you've got the sign right, which is why I put it in as minus a minus to start, because the h is a negative, and that's why it flips the sign. So our problem here is we don't know what a is. If we knew what a was, then we would be done. We'd have our equation. Here's where having this point that lies on the parabola is important, because what I really have is an x value and a y value that lies on this parabola. And so what I can do is actually take the value of that point, plug it in for x and y, and the only variable that I'll have left to solve for is a. So let's go ahead and do that. I put the 2 in for y. Okay. I put the negative 5 in for x. And now it's just a matter of simplifying and solving for a. So here's what I have. I've got 2 equals a times negative 2 all squared plus 6. So 2 equals negative 2 squared is positive 4. Remember, whenever you square a number, it turns out positive. So that's actually 4 times a, which is 4a, or a times 4. So again, this here is 4. A4, we don't do A4, then somebody's going to yell bingo. We put the 4 in front. Okay, plus 6. Now I'm just solving a two-step equation at this point. So, subtract 6 from both sides. I get negative 4 equals 4a. Now I have to divide both sides by 4. And a equals negative 1. So I can get my equation. I can just substitute that back in. So my final equation in vertex form, because now we're just going back up to where we were. We were right here until we solve for a. So now I know that a is negative 1. So it's just a matter of writing that out. Oops. Y equals negative 1 x plus 3 quantity squared plus 6. So now we've written our equation in vertex form. We've figured out what a was, and all you have to do is use the vertex and a point on the parabola, and we can come up with our vertex form.